Hello, and welcome to this short tutorial about dealing with missing data. Okay, so today we're going to be looking at some data from the coaching psychology module. So I'll just open that up now. So missing data is something that's really common in real world data, and that can be where someone has perhaps not completed one question in a questionnaire, for example, or that they have completed it but to an extent that you can't read their answer or so on. So there are different reasons behind it, but it's important to know how to deal with that when it occurs. So in this case, what has happened is, if you can see people's scores on the STAI, you can see down here on this row, this individual, this participant, has obviously not completed. And so what the researcher has done is to enter a value in that cell which is highly unlikely or impossible to have occurred otherwise. So in this case, 999. Other approaches are commonly to use the value, say, minus 99. So it's something, a value that you wouldn't find in the normal range of the data. You can enter that to distinguish it being missing data from completed data. Another common approach is to leave the cell blank. So for example, it would look like this. And what this is called, particularly when you're using SPSS, is system missing data. Okay, but this time this is user specified missing data, so 999. Okay. So what will we do with that next? Well, it depends what your aim is, but in this case we're perhaps going to use SPSS. So what would be helpful to do is perhaps get this data set into SPSS now. So one way to do this is to slightly change the way that the data is laid out, and we can directly import this then into SPSS. So I'll show you how to do that now. So if you just highlight the top, these first three rows, when we want to import it, what we want to have is the first row of data here, the first part of the information, to be the variable names that you want to import. So in this case, we're going to remove these first three rows, delete those, and now we've moved everything up. So our first row is essentially our variable information. Okay, so I'm going to save that. Minimize that, and now I'm going to open SPSS. So I'm using version 23, but version 22 and version 24 are very similar. Okay, so what I'll do is, for the moment, I will just click on New Dataset. Okay, so what this has done is opened a blank data set. What we could do is copy and paste across the information from our Excel file, and then add some further information about it in the variable information file here. But we're not going to do that. I'm going to show you a way of importing the data. So if you go to File, Open, and Data, I've saved my file on the desktop. So I'll go back to the desktop. Now you can see here you can't find it at the moment, and that's because we're currently searching only for SPSS files, but ours is in an Excel spreadsheet. So if we just change this to file type Excel, now we can see our copy of the data. Okay, so that's the one we want to open. So if you click on that and open, it'll ask you this. So it's saying, this is the source that are you trying to open in SPSS, and that is the right one. This is the important box here that's ticked. Read variable names from the first row of data. So that's why we've just slightly changed our data file in the Excel spreadsheet. Okay. So click OK. You can see in the bottom right hand corner here it's saying running execute. Okay, and now it's opened our data. Okay. So it's really important when you've done that, you just want to check that it all looks like it makes sense. It has copied across your data. And we can see here the completed data, and then the example we looked at in the Excel spreadsheet, this participant who has not completed the STAI at time 1. Okay. But this is usually not complete once we've done this. So we'd look at our variable view and we can manipulate the data from here. So it might be that we want to give these values a slightly different name. We want to check if they're set up correctly. So all of these are numeric, which is great. We can see here that it's given a name and it's removed all of the spaces between the words, because you can't have spaces as a variable name in a variable name, in SPSS. But here we've got the complete original name in the variable label. One thing to check is what we've got here is gender. You can see that that's a string variable, and what that means is that it's a word variable. Okay, so that's because in our original data set we had people identified as either female or male using the word. What we might want to do at this point is to convert those to numbers. So to go through each of these, and instead of female, perhaps we would choose 1, and male we would choose as 0, and then do this all the way through the data set. So 1, 0, 0, 0, 1, and so on. Okay, so I've gone ahead and just done that. The reason you would do that is that for some types of analysis you can only enter a variable that is classed as numeric, not string. So it's good practice to sort of do that on the early stages. So we would change this now to numeric, and I'll apply some labels. So if we remember, we coded everything that was 1 was originally female, and then we add that, and anything 0 was originally coded as male. So we'll add those, and now what we can do is go back to our data view. There's a button at the top here, and this turns on your value labels. So what we can do is turn that on, and we can see here. So although we've now changed the data to numeric, we can still eyeball it as the word variable as well. And what would be good practice is to just double check against this to make sure that we have completed that appropriately, so we haven't made any mistakes. But I'll leave that for you to do. Okay. So the next thing you want to do is to double check everything else. You can change this, your decimal places, check that these are correct. So nominal, yes, those are correct. The others are scale. That one might be nominal. Okay, but all those look correct. So what are we going to do about this missing data? Now, by default, if you had a blank cell, SPSS would treat that as something called system missing data. But what we've done is specified that it's missing. So we need to tell SPSS to recognize anything entered in this view on these variables with the value 999 is to be treated as missing data. So we click on the variable view, and you notice here we've got a column called missing. So if you've got no missing data, or if you've chosen to leave missing data as blank cells, so system missing, you don't need to do anything further. But as soon as you know you have missing data and you've specified, and sometimes that's a useful practice, you can use different values to identify different types of missing data. So it could be missing data that someone just didn't complete, or that was illegible, so that you couldn't interpret. So you can actually specify different numbers for that, so that further on you could look at the differences between people who completed but whose writing you couldn't read, for example, if it's a hard copy, or for those who just didn't complete at all. So in here you click on the right hand corner of the box and it'll bring this up. And in this case we've only used one value, which was 999, so we would enter this here. If we'd use different types, we have up to 2 other options we could include to be classed as missing data, or we could use something like this. Okay. In this case, we've only got one type of missing data, and we've coded that as 999. So if we click OK, it'll appear. So you'd want to do that on each of them. So each of these variables that could have the missing data. What you can do is right click on the box, click copy, and then click and hold to highlight all of these, right click, paste, and you'll see your missing values appear across all of the variables here. Okay, so when you look back at data view, it won't change this view, so these values will still be here, but it means that when you start to run analyses, it will count that as a missing variable and it will exclude it from the analysis in different ways. And it's really important to remember that that can be done usually in two different ways in SPSS. So if I show you perhaps with correlation, so if we go to Analyze, Correlate, and bivariate, so this looks at the way that two scale level variables, or potentially ordinal if you do a Spearman's correlation, but two scale level variables relate to each other. So I'm just going to leave it as Pearson's for the moment, just as an example, but it's important to remember that you would need to have done all your data assumption checking before you choose between a Pearson's and a Spearman's, for example, as to which test is appropriate. But in this case, I'll just leave it as Pearson's just to demonstrate the use of the missing values. So I'm going to transfer these two variables across just to look at them. And what I can do is go into Options, and this is where you tell SPSS how you want the missing values to be treated in your data. And this is common across a lot of the tests. So things like regression as well, you can specify between pairwise and listwise. So what pairwise deletion does, or pairwise exclusion, it will look at if one variable has missing data, and you're using that in an analysis with another variable, it'll exclude the missing cases only on that analysis. But if that person has complete data and you're looking at other analyses, then it will include them. Excluding cases listwise, as soon as that person has missing data on anywhere on the pairs of variables you're looking at, it will exclude them across the entire set of analyses. So if I demonstrate that here, so in this case, we've only transferred two of the variables across, but say if we transferred them all across. The difference would be in pairwise, if participant 1, for example, had missing data on this T1 variable at the top, and you were looking at the way that this variable related to the second variable here, y2 here, but they had complete data on everything else, it would include them in the analysis for everything else except this one here, for example. So if you're looking at the relationship between y1 and y2 here, then the person's data would be excluded because they've got the missing data on this variable. But if you were looking at the relationship then between y2 and student motivation and so on, it would include them because they have complete data on those variables. So it would only exclude it on the analysis where they've got the missing data. Listwise, that person, if they had missing data on this variable but complete data on everything else, they would be excluded from all analyses because they have missing data somewhere. So there's two core ways of handling the missing values in your data set, and they can have quite a big impact. So one of the reasons that people use listwise is that means that you can have sort of uniformity. So you're always looking at the same group of people, which sometimes that can make it easier to interpret your conclusions. But what happens then is you can arbitrarily lose a lot of information. And as part of that, you can lose something called power. So the chance to identify something as significant, even if it's out there, if you don't have enough data, you can't detect it. So that's why some people use pairwise. So it would just be important to say how you treated the missing values so that the person reading your results, for example, knows what you've done and the potential impact of that. So in this case, I'll choose pairwise. I'll click continue and I'll run OK. Okay. So what this means is you can see here this is the first variable on our data set, and we have the first variable in our data set linked to every other variable in the data set. So what's the relationship between STAI-Y1 at time 1 to STAI-Y2 at time 1, and so on. And what we can see here, we have something called N, and that is the number of cases that each of these correlations has run on. So on the first one, we can see it's between T1 STAI-Y1 and between STAI-Y2. And you can see that this is run on 32 cases, and you can see the correlation coefficient and the significance value for that as well. But actually, if we come across to the relationship between T1 STAI-Y1 and T2 STAI-Y1, you can see that's only run on 23 cases. So what's happened is that we have more missing data for this relationship than this one. So we can see that the number of cases across our analyses can change because we've made the most of the data, the complete data we do have, and excluded those cases where we have missing data, only on looking at the correlations where it's relevant to do so. Okay. So if I rerun that, but this time I choose listwise, you'll see the difference. Click continue, click OK. So we're still doing the same thing, correlations, but we can see this time, instead of having N in each column and row, it's just put it at the bottom, and in this case, it's only on all of those cases that have complete data across every single variable, which is 23. So we know that only 23 of our sample provided complete data across every single variable in our data set. So that's what this analysis is run on. And what you can see here is the difference that that can potentially make to looking at relationships. So in this case, if we look at T1 STAI-Y1 and the relationship between that and STAI-Y2, this has now been run on only 23 cases. Originally it was run on 32. So we can see here that correlation coefficient is 0.508 and the significance is 0.013. If we scroll back up and look at that same relationship but run on the 32 cases, you can see that there's a difference. So how you treat your missing data when you're running your analyses can have quite a large impact on your findings. So you just need to be clear about what you're doing and why.